All right, so here we are on the second part of this getting a little bit of algebra. And last time we talked about um, how really an equation is just like any other arithmetic problem. The only difference is that in an equation, typically we don't know all the players. Here we knew the 12 and the 6, and all we had to do was add them up to get 18. But oftentimes in algebra, depending on what, and remember these equations should have something to do with something in the real world. They express something in the real world. In algebra books, we saw pages of equations and have no idea what they're all about. They're just practice in practicing the mechanics of moving them around. Okay, and we're really not going to cover anything a whole lot more difficult than what I've already covered here. We just need to look at a couple more examples maybe to get kind of the idea. Here we were looking at addition, and subtraction works the same way. Let's take the same numbers, 12 minus some value is equal to 18. Now x is going to be a different value here. Perhaps. How would be our approach to this? Well, first of all, locate the variable. And then find out what's being done to it. Well, we have a value of 12, and we're subtracting x from it. Okay. Well, I can't very well add x to both sides. Well, I could, but all I would do is move it over here. And there's no sense in doing that. We could eventually get to an answer doing that, but we can do it a little more quickly. We could say that a positive 12 is having x subtracted from it. If this is a positive 12, let's subtract 12 from both sides, like we did before. And so we get 0 here, which I'm not going to write, and we're left with this minus x. That subtraction sign is also the sign of the number. Remember, in algebra, we're dealing with negative numbers too. So we get negative x is equal to 6. Now, we know when we solved it here and 12 was being added to, we got a positive 6. X can't be both negative and positive, and you're right. But we haven't really finished solving this, because in front of any variable, there's an invisible 1. If there's no other number, there's a 1. So it doesn't matter. I got m, there's a 1 in front of it. Okay. So this is really minus 1 times this letter. Whenever we put a number, and we'll solve this equation here in a minute, whenever we put a number in front of a letter, the implied math operation is multiplication. Since this is algebra, rarely is the little x, like 2 times 3. Okay, this is not used because we use the letter x is the one used the most probably in algebra, so don't do that. Just being next to each other means that the two things are being multiplied. You will rarely see the dot, which also means multiplication. So what's really here, though, is a minus 1 times this. Okay. Since this is multiplying this, and I recognize now, since this has that minus sign in front of it, that there's a minus 1 there, I can do the opposite of multiplying by dividing. So I will divide by a negative 1. Negative 1 over negative 1 is just 1, and 1 times x is just x. So now we see that when we divide 6 by a negative 1, we will get a negative 6. So in this equation, because of this operator here, x has to equal a negative 6, where up here it equals a positive 6. And this is where you want to keep your calculator handy. If you're not sure about how to deal with numbers that have positives and negatives in front of it. If I have 6 and divide it by, and this is the negative sign up here, not the subtraction. Your scientific calculator will have a negative sign. Divided by -1, notice that it comes out as -6. Okay? All right. Just to practice this idea a little bit, we added a number up here. Let's take this equation right here. We're not adding anything to x, we're multiplying it by 2. So how do I solve this equation? My focus goes to the x. What's being done to that x? Well, it's being multiplied by 2. We're going to be like stubborn 2-year-olds. We're going to do the opposite of what they're doing here. Oftentimes, in isolating things, we want to do the opposite operation that's being done. So if 2 is multiplying the x, let's divide by 2. But remember that golden rule of algebra. Whatever I do to one side, I need to do to the other. And that rule, by the way, is what makes this whole mechanical adding, subtracting, multiplying, dividing both sides of the equation. That's the magic. That's what makes it work. Notice what happens. We get 2 divided by 2. Well, anytime the numerator and the denominator are the same, that results in 1. And 1 times any number, it doesn't matter what the number is, it will always be whatever the number. Okay? And 1 times x is just x. So those cancel. So x then is equal to 6 divided by 2. Well, I know what that is. 2 goes into 6 3 times. That's the mechanics of algebra. And of course, in algebra books, they like to get a lot more complicated or whatever. Okay. Let's do another quickie here. We got time for one more problem. All right. Much like the addition problem. In solving this, the first thing I want to do is find my variable. There's my x. And then I ask, well, what's being done to it? Well, it's having 17 subtracted from it. Well, how do I get this x by itself? Well, if I add 17 here, this goes to 0. That will leave x by itself. So I will add 17, but I must do it to this side as well. So that goes to 0, and x then is equal to 5 and 17, I think is somewhere around 22. Now here's kind of a neat thing. Once you get a value for x, you can find out if you did the problem right by taking your answer and putting it back in the original problem. 22 minus 17 equals 5. So if I have 22, I'll do it on the calculator. 22 minus 17, because I'm horrible at arithmetic, is indeed 5. So this answer checks. You can always check your answer. Okay, and let's do another quick multiplying problem. All right, so where do I start? I find my x. I ask the question, well, what's being done to it? 3 is multiplying. All right, well, what's the opposite of multiplying? It's dividing. And I'll draw my line here for dividing, and I'll draw it here as well, because whatever I do to one side, I need to do to both. Do I want to divide by the x? No, because then I wind up with 9 over x over here. That doesn't help. I'm trying to get rid of this 3. If 3 is multiplying x, then dividing by 3 will get rid of it on this side. But I have to divide by 3 over here. So x then is equal to 9 divided by 3, or 3. And if I put that back in the equation, 3 times 3 equal to 9. Well, 3 times 3 is 9, and 9 does equal 9. So yes, That is the answer. All right, more in the next video.